Hello, this is Bhaskar Bharati. Today I'm going to give the presentation on my topic ThreadX Microsoft Express Logic. So let's get into it. First, let's start with the its descriptions. So basically, ThreadX is a real-time operating system (RTOS). It is created by Microsoft Express Logic, and it is recognized for one of its like high efficiency, compact size, and also the effective resource management. And it is designed for the embedded system like IoT devices, microcontrollers, medical devices, automotive systems, and other applications where responsiveness is crucial or important. So let's get more into it. Let's say its key features. First, it's determine the real-time performance. So the performance of the operating system is determined by this system, and also the quick content switching, and it does the multitasking where we have the two multitasking, that is primitive and non-primitive, but this ThreadX is designed for primitive multitasking, and also have the low memory footprint, which is one of the I think important for the operating system, and event chain technology, and it is one of the like priority based one. So we can have like a lot of features on that too, and also it is also one of the determined behavior. So let's go get into the more into this. So let's see its history. So history of ThreadX. It is first designed in 1999, which is count as embedded file systems. So there at the time there was File X was released. So slowly at the time in 2002, ThreadX embedded like TCP or IP networking stack was released. That is NetX, and also in 2004, USBX, which is called also the embedded USB support was released. So we can see that like time by time it is growing with the networking stack, with the USB support, and also in 2009 the ThreadX SMP was released for multi-core environments. So in 11 it have like the ThreadX modules were released too. So ThreadX obtained safety for the safety too. It created a lot of certifications like for UL 60730 in 2014 was released, and TUV IEC 61508 in 2013. But we can see most of the design was created since 1999, but the major changes was released on 2014, which saw the release of GUIX. That is one of the best embedded user interface. So that's how the interface is uh, developed for this operating system. So Microsoft also acquired like Express Logic on April 18, 2019. Recently, it has. So that is the one of the history of how ThreadX is developed. And if we see the design pattern of ThreadX, it is basically priority based scheduling, which means it utilizes priority based primitive scheduling for efficient task management. So, which is needed for the processors, it release that kind of resources for it. So also it have the modular architectures, which means it supports dynamic loading, unloading of modules for the operations, and a small footprint, which optimized for minimal memory uses, ideal for resources devices. And if you see its more design pattern, it is also evolved or developed for the inter-thread communications, which means robust mechanism including message queue systems, semaphores, and mutexes. And also in the deterministic behavior, it ensures predictable performance, which is very crucial for real-time applications. And besides all these features, there is one of the important, that is safety and security pattern too, which compliant with the industry standards like mostly suitable for all of the like safety critical applications. So this is an overview for the design pattern of the ThreadX. So how it is implemented, if we see its implementation part, actually thread management is like created. So its implementation is first, like let's say it's for its management, how it manage. So creation and deletion of the threads is there, which is assigned with specific prioritize. And also there is the management of various thread states, like the concurrency we can say. There is the state, different state, like ready, running, suspended, and so on. So that is one of the thread management, which is overview. In summary, we can say it's like it manages the concurrency, multiple threads at a time. And also, of course, it is an operating system, so it have the memory management. It have the implementation of memory management, where it efficiently manage of memory pools for dynamic allocations. So for dynamic allocation, it have that features too, and also the byte pool supporting variable sized memory blocks. So this is one of the implementation to implementation. Let's go deep into this. We have several few more implementation of ThreadX. So there is the internal thread communications too. Asynchronized communication is there through message queue and synchronization using binary and counting semaphores. And also there is on inter-thread communications, they have the protection of shared resources with mutexes. And on the event handling features implementation, it utilizes of various flags for various multi-purposes, multiple events waiting with logical operations. And also for the software timer system, for implementing like delays and periodic task executions. And also on the integration and portability sides, ThreadX is implemented on mostly on a hardware abstraction layer HAL, which is called for simplifying hardware specific operations. So compatibility with also various development tool chains and semiconductors like SDKs. So this is these are the implementation of ThreadX. So how its components, like how it is made actually ThreadX, let's go deep into that. So the main subcomponents of ThreadX are like kernel, threads, thread control blocks, scheduler, interrupt handling, memory management, interthread, and synchronization, and software timers. So these are the most important and like the subcomponents of ThreadX. So for the kernel, it manages threads, scheduling, and resource collection. For the for the thread control blocks, the data structure it will that manage it, and scheduler it handles thread scheduling, and it also handle the interrupt handling, which means it manages most of the interrupts between the processors. And main thing is like memory management. It manages memory allocation and delocation, which is one of the crucial features for ThreadX. And also on the synchronization part, it provides mutex semaphores and even flags. And timers manages timers for periodic taxes. So these are the subcomponents of ThreadX. So if we talk about on the hardware part, physically part components of ThreadX, there is it is made of like microcontrollers, microprocessors, and if you see on the components of that too, we have safety like different certifications too. So microcontroller controllers, it have like ARM, PIC, MIPS, RISC-V, and more. So on the microprocessors, it like 86 bytes and power PC and others. So what the applications of ThreadX? So if we talk about the applications of ThreadX, it is like consumer electronics, like for example, smartphones, home appliances. These are the applications of ThreadX where we are using in our daily life. In automobile too, automotive too, it have like the driver assistance system. It works on that. So that's operating systems is embedded in that automobile, and various medical devices like for example patient monitoring system, diagnostic equipment. So in various field of medical too, ThreadX is highly used and recommended. And in the industrial automations, control system, and robotics, it is also implemented on that too. So and most important thing is Internet of Things, IoT. So for example, sensors, we can say gateways and edge devices. So these are the most important applications of ThreadX where it is implemented or the used. So, if we talk about advantage of ThreadX, like as we said, it has implemented a lot of features and it is used by many applications, like in medical wise, in automobile, so in various big industrial automations. So let's talk about its advantage. So, so it is embedded. So for that reason, it has high performance. That means it have like fast content switching and low latency. So on the scalability side, it supports multi-core processor, and reliability side, it have like most of we already sees that it have extensive safety certifications, and size, it have minimal memory footprint, which is one of the good side of ThreadX. And also on the flexible side, it supports various scheduling policies and on the fly property updates. So as it have advantage, let's see its drawbacks or disadvantages too. So on the complexity side, if we see, it requires a good understanding of actually the RTOS concepts. So it's not that complex, but it have to have like the good understanding. And also on the resource intensive, it may require more resources, like as compared to other simpler RTOS solutions. So on the resource intensive side too, it have its one of the disadvantage. And learning curve, if you are really beginners or the new, so new users may find it's like challenging to learn and implement. So because of its like more implementation and a vast system, it is one of the it is very it's very, which I can say is like very hard for the new beginners to learn this understand this ThreadX actually what system is. And and let's talk about its future outcome. What is its perspective in the future? So future outcome, if we see, it is, as we said, like it is multi-processor core, it supports and it has many applications, many are using these applications, so it is expected to continue evolving because of those features, with improvement performance and also scalability and support for emerging embedded hardware platforms. Its open source model under the Eclipse Foundation will likely attract more developers and foster innovations. So this is one of the future outcome we can see for the ThreadX. And on the conclusion side, so if we conclude or summarize, all the concepts or all the overview of the ThreadX, as I discussed, is like it is one of the robust and versatile RTOS that is well suited for a wide range of embedded applications. So it's a small footprint, that's the main thing, has high performance and extensive have it has extensive safety certifications, make it popular choice for developer in various industries. So these are the outcome and the future. These are the summary and the future outcome of the ThreadX. So thank you so much. So these are the most of the topics I covered. I think it's included everything relating like how it's developed, when it was developed, and what are the implementations, what are the advantages, what are the disadvantages. So these are the topics I really covered for my term paper too. I hope this gives an good idea or a small overview of ThreadX Microsoft Microsoft Logic Express. Thank you.